For most of its journey through the dark, 3I Atlas existed as a distant problem. A faint signal, a moving variable, a clean line on a trajectory plot. Something scientists could study from comfort. But in the past few days, that changed. Because 3I Atlas just crossed what researchers call a critical threshold. The point where long-range models give way to short-range reality. And when that happened, the data stopped behaving calmly. Until that moment, everything about the object was still floating in the realm of uncertainty, estimates, predictions, probability distributions. But crossing the threshold does something to the science. It removes the fog. It replaces speculation with measurement. And suddenly, the story sharpened. Not in a reassuring way, in a way that forced NASA and other agencies to switch from passive observation to active response mode. Not panic, not emergency, but strategic attention. Because when an object stops being theoretical and starts being measurable, it becomes real. And something real can't be ignored. The critical threshold in this case refers to a point where 3I Atlas entered a region of space close enough for high-fidelity sensing, a zone where radar data becomes meaningful, where thermal mapping becomes accurate, where spectral noise drops low enough for deep structural reading. Before this, scientists were working with shadows. Now they're working with substance. And when that data came in, some of the assumptions driving earlier models had to be scrapped almost immediately because the object wasn't behaving like it was supposed to. NASA analysts noticed the first red flag not in its orbit, but in its response to solar radiation pressure. Space objects react predictably when exposed to increasing sunlight. They heat up, they outgas, they reflect. 3I Atlas didn't. At least, not normally. Instead of showing the chaotic venting expected from an interstellar comet or rock, its energy response was unusually controlled. Not smooth, not aggressive, but managed, as if the surface wasn't simply absorbing and releasing heat randomly, as if certain regions were insulating, redirecting, or regulating that energy, which is not something dead rocks do very well. That anomaly triggered a change in classification. Not officially, but internally. It moved from a passive observation object to an active monitoring object. And that's where the reaction began. Because when NASA starts assigning real-time analytical resources, it means the data crossed a line where ignoring it would be professional negligence. But here's the surprising part. The reaction wasn't public panic. It wasn't alarm. It was restraint. Instead of dramatic announcements, what came out were carefully controlled updates using vague but revealing language, behavior exceeding prior models, complex interaction with solar exposure, unanticipated consistency in internal thermal response. To the public, these sound like harmless scientific phrases. Inside the field, those words mean something doesn't fit our rules anymore. One of the main triggers was a change in its light curve behavior. The light curve, the way its brightness varies as it rotates, is one of the best indicators of an object's shape, spin, and internal density. Comets normally show noisy light curves. Asteroids show cleaner ones. 3I Atlas showed a pattern that sits between. But now, after crossing the threshold, the pattern sharpened. And what they saw was worrying. Not because it was bright, but because it was predictable. Its rotation cycle showed unnatural stability. Not perfect, not mechanical, but too consistent for a tumbling, eroding piece of interstellar debris, which implies something holding it together internally. Not just gravity, not just frozen ice, but structure. Structure changes everything. NASA didn't react because of fear. They reacted because structure implies complexity, and complexity demands attention. Another major reason for the response was how the object interacted with surrounding plasma. As 3I Atlas moves through the solar wind, the stream of charged particles emanating from the sun, instruments watch how that plasma moves around it. Most objects create messy, turbulent wakes. 3I Atlas created a surprisingly neat disturbance field. Not smooth, but shaped, like airflow bending around a defined body rather than crashing into a random rock. That's not threatening, but it is unusual. And when unusual appears where chaos usually lives, scientists don't look away. They lean in. This led NASA to increase deep space tracking priority, which means more resources, more time in antenna arrays, more scheduling on orbital telescopes, more cross-agency collaboration. They're not doing this because they think it's dangerous. They're doing it because they think it's important. And in space science, important often precedes paradigm shifting. What really forced the reaction, however, was something quieter. It wasn't visual, it wasn't thermal, it wasn't even magnetic. It was the mass estimation update. As better models and real-time tracking converged, the mass of 3I Atlas had to be recalculated. And when it was, the numbers didn't just move slightly, they jumped. Meaning this object carries far more material than earlier projections. And mass means inertia. Inertia means stability. Stability means survival. And survival across interstellar distances is not random. Most things don't last that long out there. The space between stars is not empty, it's brutal. Radiation storms, micrometeorite erosion, thermal extremes. Anything unstructured eventually degrades. 3I Atlas didn't. And NASA reacted because objects that survive conditions like that deserve deep attention. Not fear, just scientific respect and careful scrutiny. Behind closed doors, the discussions now aren't centered on what it might do. They're centered on what it might represent, because if it is just a rare natural formation, its properties stretch the limits of known astrophysics. And if it's not, then it suggests something else existed before us, long before, not necessarily still out there, but once real, once capable of creating things that persist across cosmic time. And that idea is heavy, not scary, just heavy. The public updates from NASA have stayed clinical, measured. But if you listen closely to the phrasing, the shift is there. They're no longer saying an unusual interstellar object. They're saying a complex interstellar body displaying anomalous structural behavior. That's science language for, we don't have the box for this yet. And they hate that. Scientists love boxes because boxes give you comfort, control, understanding. 3I Atlas is pushing outside the box, and that's why the reaction happened. Not because of threat, but because of implication, because of scale, because of history. Because if this object truly crossed this threshold and continues to behave the way it is, then it won't just be remembered as an interstellar visitor. It will be remembered as the moment we realized the things that pass between the stars aren't always just rocks. Some might be residues, some might be remnants. Some might be the physical echoes of intelligence that no longer exists. And that thought makes agencies like NASA do the only responsible thing: watch closely, silently, not to warn, not to scare, but to understand. Because when something unknown crosses a line, the real danger isn't the object, it's misunderstanding it too late. And that's why, when 3I Atlas crossed this critical threshold, NASA didn't panic. They did something much more serious. They paid attention. And in the world of space science, attention is never given lightly.